Could I speak up louder?
Neil, this is God. I want you to shut up.
Okay. What do you guys see that's different about this code? Semicolons are missing. I define an object instead of a class. But let's go back to that semicolon thing for just a second. Why do we need semicolons in Java? Because the compiler is stupid. I mean, if you write some Java code and you leave off the semicolons, what does the compiler tell you? It tells you, you left out a semicolon right here. Wait a minute. If you know I left out a semicolon there, if you know that the error in parsing is because I left out a semicolon there, why didn't you just put it in? Or just ignore it, or just accept it. The semicolon is there basically for historical reasons, right? 95% of the time, the semicolon is not necessary when you're looking at Java code because the semicolon is like the first of a two-part key sequence, right? Your finger hits the semicolon and then your pinky goes straight to the return key. So why do we need the semicolon again? Scala says we don't. And this creates a very interesting idea because, as Neil was saying in the previous lecture, when we start talking about wanting to introduce internal DSLs, a lot of the punctuation characters that we have to wrestle with, semicolons and dots and parentheses and so forth, the more of those we can get rid of, the more approachable to non-technical people our DSLs will be. So this is just one tiny little syntactic thing that Scala introduces that makes Scala that much more interesting for DSLs. Now, second thing, we notice that I'm not doing a class, I'm doing an object, right? When we talk about classes and object-oriented programming and so forth, class is basically this factory, this cookie cutter, this type definition where an object is an instance of that. Based on that definition, what do you think's happening there? I'm implicitly declaring a singleton object, right? Because singletons have kind of, is there anyone here who does not know what a singleton is? I mean, it's that common a concept right now that why not give it first-class support in the language? Now, the interesting thing here is, if you look at this singleton definition, right, it has one member inside of it, which is called main, right? And if we go back to our traditional Java semantics, main has to look like what? What's the syntax? Public, static, void, right? All that good stuff. Well, here I haven't put any of those decorators around it. So how does Java know that this is the thing to execute? And this is where the Scala compiler is actually doing some interesting things. We start by looking at hello world, right? And notice hello world, a public final class hello world extends Java-lang object, public static final void main. In other words, because this was an object, because this was a singleton instance, it said, I'm guessing that this definition of main here wants to be a static method. And I'm guessing you want it to be public because you haven't put any other access control specifier on it, right? The fact that Java says the default specifier is, well, it's not public, it's not private, it's package. Why? How many times have you written a package qualified member? A lot? Sure. For unit testing purposes only. But in your domain code, if you're building domain objects, the stuff that people other than you care about, right? How many times do you create a package level member? What do you want the default to be? The default should be the thing that you want 90% of the time, which is public. Go through any standard Java class, any standard Java Pojo, and 90% of those member definitions are going to be public. So Scala says the default is public. So that's public. The fact that it's inside of a singleton implicitly makes it static. By the way, what this means now is within the language itself, there are no statics. There is no such thing as static inside of Scala. If you want the moral equivalent to static, you create a member method or a member field on a singleton object. And now that whole argument that you have to have with the rest of the team as to whether or not it should be static methods or a singleton object goes away. Now we can get back to more important things like arguing where the curly braces should be. Okay, now notice that two classes actually got generated here. There's hello world and hello world $. One of the things that Scala is going to have to do in mapping to the JVM is it's going to have to put certain bridge characteristics in place. So for example, if we trace it through all the way, hello world main is actually going to go and find the singleton object, hello world $, which is tucked away in a static field someplace. And then it's going to invoke the standard method main, the instance method main on that object. And this is necessary in order to support the semantics of Scala and still be able to run on top of the JVM. Now, why am I telling you this? Because when you're a Scala programmer, you don't care about how it maps to the JVM, and this is just extraneous noise. But the practical reality of the situation says 90% of the time when you're writing Scala code, you're going to be calling it from Java. Or somebody's going to be calling your Scala code, and they're going to be doing so using Java semantics. So you want to understand how Scala maps to the JVM so that you can turn around and make sure that the code you're writing can in fact be discovered by Spring, or can in fact be loaded by the EJB container, or can in fact be loaded by the servlet container, etc., etc., etc. Does that make sense? All right. Let's go on. Oh, one other thing that we missed looking at said code. What does the definition of args look like? Well, the square brackets are kind of in the wrong place. And there's this thing called array there, and it's like on the wrong side, right? If you look at the traditional Java definition, it says type and then the name of the thing. Scala flips that around. Scala says you always do the name first, and then colon, and then the type, sort of a Pascal-style notation. This is very deliberate. Remember earlier when we were talking about type inference, and where the compiler wants to try to do as much of this guessing of type for you. The only way it can do that is if there are ways for me to leave off the type without screwing up the parser. Now when Scala sees a name it doesn't recognize, it assumes that it's the name of something. And if there is any type information to be had, it will next see a colon. Otherwise, it assumes that I have to figure out what this is. So it lays down a marker in the parser stream and says, all right, I'm going to have to figure out what this type is as I go through all the semantic analysis and so forth. So it means the colon and the type is now officially optional. I can leave it off in certain cases. In this particular case, because it's going to be a top-level definition, there's nothing to infer from. It's not like we get to load up the Java launcher code and see the fact that it's looking for args being an array of strings. Because type inference, right, infer means I have something basically to compare it against to be able to make that decision. Okay? So there are going to be places where type inference will break down, and you're going to have to provide that type information. For the most part, the way you program in Scala is to leave out the type information, and when the compiler complains, then you put it in. Okay? And next question. You notice that I'm using this notion def as opposed to some other public static, etc. In this particular case, it seems fairly straightforward, but let me ask this. What is x? It's a function? How many people agree with that? I mean, bear in mind, right? I fully understand that you're just guessing because you don't know, right? And the truth of it is, I don't know either. I'm just asking that question because I couldn't remember. Do I care? Do I really care what x is? Do I really care if it's a field or a method? If you think about it, at some